Hey geometry students, so today we talked about row reducing matrices to solve systems of equations. So, first of all, when we're row reducing a matrix, the goal is to get the numbers on the main diagonal to be ones and all the other numbers in that square to be zeros. And then the numbers over here are going to represent the values of our variables. So if you had a system of equations like this one, probably came from x minus y equals negative 12 and negative 3x plus 2y equals 32. So that's a system of equations that this particular matrix came from. And to solve that system, we want to get this matrix into this format using row operations. So we're going to do that real quick here. And this is a simple one. We've got 1, negative 12, negative 3, 2, and 32. Okay, so the first thing we're going to do, we want to get ones on the main diagonal here, which we've already got a 1 right here. So that's good, but we want to get this number below it to be a 0. So to make that happen, I'm going to take row 3, and I'm going to add 3 times row 1 to that. So when we do that, we've still got the top row is the same, 1, negative 12. But the bottom row is going to be negative 3 plus 3 times 1, which is 0. 2 plus 3 times negative 1, which is negative 1. And 32 plus 2 times negative 12, which gives us negative 4. Or sorry, 3 times negative 12, my goodness. Yeah, so that's negative 36, and 32 gives us negative 4. There we go. Okay, so now I'm going to take the second row, and I'm going to multiply it by negative 1 because that's going to give us our second 1 on that diagonal. So I'm going to go row 2 times negative 1. And we get 1, negative 12 still on the top row. Then we get 0, 1, 4 on the bottom row. Now the last thing I need to do is to get this number to be a 0. So to do that, I'm just going to take row 1 plus row 2. And when we do that, we get 1, 0, negative 8, and 0, 1, 4. So what this tells me is that x equals negative 8 and y equals 4 if we were solving this as a system of equations. Otherwise, our solution is just these two numbers, negative 8, 4. All right. Hopefully this was helpful. It's the same process when you're doing it with a 3 by 3 matrix that's augmented, like in number 3. Except for number 3, you're trying to get the format with 3 ones on that diagonal and zeros elsewhere, and then it's going to represent the solutions x, y, and z if this were a system of linear equations. Let's see, what else? Remember, 1 and 3 are the only ones I'm asking you to do by hand. The others you can put into a calculator. All right, have a great day.